bottles are not only piling up in our landfills and oceans, it turns out they also shed plastic particles that end up in our bodies. According to a study by scientists from Columbia and Rutgers universities, on average, a 1-liter bottle of water contains about 250,000 invisible nanoplastic particles. The study was published this week in Proceedings of the National Academy of Sciences. Phoebe Stapleton is one of the researchers on the study. She's an associate professor in the Department of Pharmacology and Toxicology at Rutgers University. She joins us now. Phoebe, welcome.
Hi, thank you for having me.
So Phoebe, what exactly is a nanoplastic? I'm wondering if it's actually plastic given it's so tiny. And how is it different from microplastic?
So a nanoplastic is indeed a piece of plastic, just a small particle, and it's about 1,000 times smaller than the smallest of the micro-sized plastics. So about a grain of sand, or anything smaller than a sesame seed, and nano are more than 1,000 times smaller than that, so invisible to the naked eye.
So how did you find them in the water?
Well, so scientists have kind of known or had a feeling that they were there once we found the micro-sized plastics. And it took some time to find and develop a tool that would be able to identify the nano size given that small size range. So we were really lucky to be able to work with Dr. Min and his team at Columbia University, and they had developed this tool about 15 years ago, this SRS Raman technique. It uses 2 different lasers to be able to identify the size of the particle and, more importantly, to be able to identify the chemistry of the particle.
Okay. And so when you find all these nanoplastics, the study seems to indicate that it comes from the bottle itself and were not introduced into the water earlier, before it was bottled. How do you know that?
That's one of the theories. So we looked at 3 different brands of water, and we looked at 5 replicates within each one of those brands. And the interesting thing was the type of plastic that had the highest percentage there was different in each one of those brands. And so it was pretty clear that those plastics came from the bottling or the capping process itself, from that part, because the plastics were the same type of chemistry. However, the other 2 brands were not the same type of chemistry as that bottle or the cap itself. So it's likely they were introduced not from the bottling, but from an earlier source within the bottling process, whether that's the filter or possibly the water that came in to start.
And do we know what the health impacts are of these nanoplastics as they enter the human body?
So we don't know all of the health impacts yet. Those are still under study. We do know that not only can these plastic particles breach or bypass the environmental filters, but also the body's natural barriers as well. So we know that they get past the barrier of the lung. We know that they get past the barrier of the GI system. These micro-sized plastic particles have been identified in human placenta, human lung tissue, human blood, and our laboratory models mimic that as well. The problem with the plastics is that they may contain some chemicals that are known endocrine disruptors. They may also what's called absorb or add different chemicals from their life before they got into the body. So those additions could also change the toxicity of that particle being somewhere that it shouldn't be.
So plastic reusable water bottles we should ditch?
I would ditch plastic reusable water bottles.